It all started with a rock. Just a rock, sitting quietly under the sun in the dry, dusty hills of northern Greece. But when that rock cracked open, the world of science would never be the same again. I was about 9 when I first heard about Ouranopithecus. My uncle, who works at a small university museum, brought home a copy of Nature magazine one evening and laid it out on the kitchen table like it was treasure. There was a picture of a weird-looking skull fossil on the front, with big, deep eye sockets and thick brow ridges. It didn't look human, but it didn't look like a regular ape either. That, he said, pointing at the headline, might be one of our oldest ancestors. His name is Ouranopithecus. I remember blinking at the name. Ourano, what? He chuckled. It means heaven ape in Greek. Because the fossils were found near the sky-bright highlands of Macedonia. And that's how it began. My obsession. Not with aliens, superheroes, or dragons, but with fossils. Especially this one weird fossil that was telling scientists to look not just to Africa, but to Europe, to find our roots. Way back like 9 million years ago the world looked very different. Europe wasn't the Europe we know today, and the weather was kind of going crazy. Some places were covered in dense forests, others were starting to dry out into grassy savannas. Big changes were happening. And in the middle of all that, creatures were evolving, trying to survive, eat, protect themselves, and raise their babies. One of those creatures was Ouranopithecus macedonensis. The name sounds fancy, but when scientists first discovered its fossilized skull in the 1970s, they had no idea what they were holding. At first, they thought it was just another extinct ape. The fossil was found in the ravine de la Pluie, that means rainy ravine, in northern Greece. A team of paleontologists was digging through layers of sediment that had once been a riverbed. They weren't even expecting to find much that day. But then one of them brushed aside some dirt and saw it, a chunk of bone with teeth. Fossil teeth are actually a big deal. Teeth survive longer than most other parts of the body, and they can tell you a lot: what an animal ate, how old it was, even sometimes what species it belonged to. And these teeth? They were huge. Flat, with thick enamel, kind of like ours. That was clue number 1. Clue number 2? The facial structure. The skull of Ouranopithecus had deep-set eyes, a strong jaw, and a shortened face, not like the long snouts you see in monkeys. It wasn't human, no. But it wasn't completely ape either. It was something in between. That in between is what makes Ouranopithecus such a mystery and such a big deal. See, for the longest time, scientists believed that Africa was the only birthplace of early humans. After all, that's where Australopithecus was found, Lucy, the famous hominin, and then later, Homo habilis and Homo erectus. All the big stars in our ancient family tree were found in Africa. So most people thought the story was simple: early apes evolved in Africa, some of them turned into bipedal hominins, and eventually us. But then fossils like Ouranopithecus started popping up in Europe, and not just in Greece. Similar ancient apes were also discovered in Turkey, Hungary, and even Germany. It's like someone opened a secret door to a forgotten chapter of our past. The thing is, Ouranopithecus didn't live in Africa. He lived in the eastern Mediterranean, where the environment was more seasonal, kind of like a mix of savanna and forest. That meant he had to adapt differently from the apes in the dense jungles of Central Africa. He probably ate tougher foods, roots, nuts, hard fruits, which explains his massive jaws and thick molars. And here's where it gets super interesting: those same traits show up in early hominins, the ones who eventually led to us. Was that just a coincidence? Or was there a connection? The scientists studying the Ouranopithecus skull noticed something else. Unlike most modern apes, Ouranopithecus had a wide, flat face, more like what you'd see in early Australopithecus. Its orbital structure, that's the shape and position of the eye sockets, also leaned toward the human direction. And the wear patterns on its teeth showed that it was probably eating a varied diet, using strong chewing muscles, just like early bipedal ancestors. Even though there weren't any leg bones found that could prove if Ouranopithecus walked upright or not, some scientists think it's possible. If he lived part of his life on the ground, like in open woodlands or grassy areas, then standing up would have helped him see predators, carry food, or travel longer distances. And so the big question formed, one that still doesn't have a clear answer even today: was Ouranopithecus the last common ancestor of humans and chimps? If the answer is yes, then it changes everything. It means that humans didn't evolve only in Africa, but maybe in Europe first and then migrated south as climates shifted. That would be huge. Like, rewrite the textbooks huge. But not everyone agrees. Some scientists still think Ouranopithecus was just a dead-end ape, a species that looks kind of like our ancestor but didn't actually lead to us. Others argue that we don't have enough fossil evidence yet. After all, there are no foot bones, no pelvis, no spine, things that would clearly show whether it walked upright. Until those are found, it's hard to say for sure. Still, it's not just about Ouranopithecus. Around the same time, other mysterious primates appeared in Europe, like Grycopithecus, also found in Greece, and Anadoliavius in Turkey. Some of them are even older than Ouranopithecus. If all these different kinds of apes were living in Europe before the first known African hominins, then maybe we've been looking in the wrong place all along. It's like having a jigsaw puzzle, but half the pieces are missing and the picture on the box is wrong. But even with all the missing pieces, Ouranopithecus makes one thing clear: the story of human origins is way more complicated and way more exciting than we ever thought. That summer, I made a model of Ouranopithecus out of clay. I gave it big jaws, deep eyes, and a proud, upright stance, just in case he really did walk like us. I placed him on my bookshelf, right between a toy dinosaur and a photo of me on my first hiking trip. And every time I look at it, I wonder, what if he really was our great ancestor? What if, in the forests of ancient Greece, the first steps toward becoming human were already being taken, one footstep at a time? One fossil. One rock. One question that might change everything. The second time I heard the name Ouranopithecus, I was in the library after school, flipping through a dusty old anthropology book that hadn't been borrowed in years. Most kids were playing video games or kicking soccer balls outside. But there I was, staring at a black and white photograph of a fossilized jawbone, labeled Ouranopithecus macedonensis, Ravin de la Pluie, 1974. The bone looked worn and broken in places, but the teeth were almost perfect. I stared at those massive molars, flat and thick like paving stones, and I thought, that jaw once chewed real food. That face once turned toward the sun, maybe even looked up at the stars. It lived. It was both creepy and amazing. I didn't know it yet, but every fossil, every worn tooth or cracked skull was a kind of message, and people were still trying to decode it. The bones don't just tell us that Ouranopithecus lived. They tell us how he lived, what he ate, how strong he was, maybe even how he moved. And the more bones scientists found, the more clues started falling into place. Let's start with the jaw, because it's the MVP of the fossil team. The jawbones of Ouranopithecus are massive. Like, not just big for a primate, big even by modern ape standards. His molars were huge and thick, covered in enamel that was unusually dense. That's a big deal. Why? Because thick enamel usually means the animal was eating tough stuff, hard nuts, roots, bark, and maybe even gritty foods from the ground. Modern gorillas, who eat soft leaves most of the time, don't have enamel that thick. Neither do chimps. But early humans, like Australopithecus, they do. That similarity can't just be ignored. It tells scientists that maybe, just maybe, Ouranopithecus was living a lifestyle closer to the early human way than the chimp or gorilla way. Picture it, a semi-open woodland with patches of dry grass, some rocky hills, and scattered trees. Food was harder to come by, and survival meant getting creative with what you could chew. No supermarkets, no snacks, just whatever your strong jaws and smart brain could handle. Now let's talk about sexual dimorphism, a fancy way of saying how different males and females looked from each other. In Ouranopithecus, the difference was huge. Males had way bigger skulls, larger jaws, and probably weighed much more than the females. That kind of difference usually means something important in animal behavior: competition. Think of male gorillas fighting to lead a group of females, or orangutans puffing up their cheeks to scare off rivals. That's not just for show, it's about control, reproduction, and survival. So if Ouranopithecus males were much bigger, it probably meant they were competing, maybe even fighting, for access to mates. That gives us a peek into their social structure, which scientists believe might have been more similar to gorillas than humans. One dominant male, a group of females, and young ones tagging along. But here's the twist: while some things look gorilla-like, other traits don't fit that mold at all. For example, the face structure of Ouranopithecus is different from gorillas. The face is shorter, the nasal bones more developed, and the cheekbones wider. It doesn't look like it was meant for quadrupedal tree swinging like orangutans, either. Instead, the skull seems like it might have supported an upright posture. But again, we don't have the spine or pelvis to confirm it. That's what makes studying Ouranopithecus so frustrating and fascinating at the same time. It's like putting together a puzzle with half the pieces missing and no picture on the box to guide you. In 1999, scientists made another big discovery: the first female Ouranopithecus skull. She was found near the original site, still partly encased in rock. Her teeth were smaller, her skull more delicate, but the basic features matched the male's. Same thick enamel. Same flat face. Same puzzle. With each discovery, the case grew stronger: Ouranopithecus wasn't just an old ape. He might have been part of the line that led to humans. But there was one big thing missing from the fossil record: how did he move? If Ouranopithecus walked upright, even part-time, that would put him squarely in the conversation as a true hominin ancestor. But if he was a knuckle walker, like chimps and gorillas, then he might have just been a close cousin who never got invited to the family reunion. Sadly, the fossil evidence doesn't include the limbs. No femurs, no pelvis, no feet. That's the stuff that could give us a clear answer about locomotion. But scientists tried another approach, comparing the skull base. The base of the skull is where the spinal cord connects. In humans, it's more underneath the skull because we stand upright. In chimps, it's toward the back, because their heads jut forward on all fours. So where was Ouranopithecus on that spectrum? Right in the middle. That one little spot, the foramen magnum, was neither fully human nor fully ape. It left scientists scratching their heads. Some said it pointed to upright posture. Others said no, it still leaned toward quadrupedalism. Once again, the answer wasn't clear. But maybe that's the point. Maybe Ouranopithecus was in the middle of the transformation, part tree dweller, part ground walker. A creature caught between two worlds. Around this time, climate change was reshaping everything. Europe, especially the eastern Mediterranean, was drying out. Forests were shrinking. Grassy plains were spreading. Apes that depended on trees were going extinct. But Ouranopithecus? He adapted. His powerful jaws suggest he could eat tough, dry vegetation. His possible ground mobility suggests he could travel longer distances between food sources. That kind of flexibility would have been a huge survival advantage. So while other apes disappeared, Ouranopithecus might have thrived at least for a little while. Then, around 7 million years ago, he vanished too. But what if his descendants didn't vanish? What if they migrated south, across what is now the Middle East, into Africa? Back then, the continents were still connected by land. It wouldn't have been a wild journey, just a slow, steady move toward greener lands. And what if, in those greener lands, his descendants continued evolving? That's the theory some scientists are exploring now, that the human story began in Europe, and then moved to Africa, the reverse of what we were always told. Of course, not everyone agrees. Many paleontologists still say Africa is the only cradle of humanity. And to be fair, Africa has way more fossils, more complete skeletons, more evidence of upright walking, tool use, and even early brain development. But Europe has secrets. And Ouranopithecus might be one of the biggest. That's why people keep digging in places like Greece, Turkey, and Bulgaria. Every bone, every tooth, every fragment could shift the story. Maybe the next clue is already buried in the hills of Macedonia, waiting for the sun and a pickaxe to find it. In my notebook, I've drawn a map of Europe and Africa covered in dots where fossils were found. Greece has a big star on it. I wrote Ouranopithecus equals, underneath. I don't know the answer yet. No one does. But I think that's the most exciting part of the whole thing. The truth isn't buried in a single fossil, it's buried in 1,000 questions. And maybe, just maybe, the next one we answer will lead us right back to the beginning. In science class, when we talked about evolution, it always started in Africa. Always. We'd look at charts with a line of apes slowly turning into humans, first hunched over, then standing taller and taller until they became Homo sapiens, just like us. And where did it begin? East Africa. Every time. But one day, I raised my hand and said, "What about Ouranopithecus? That one's from Europe, right?" My teacher blinked. She didn't say no, but she also didn't really explain it. Just said, "That's a debated theory," and moved on. But I couldn't stop thinking about it. Why did we ignore Europe in the human story? Why did fossils like Ouranopithecus, Grycopithecus, and others seem to be pushed aside like old rumors? This part of the story is about those forgotten apes. The ones from Europe. The ones who might have changed everything if only we'd listened. Let's rewind time. Not by centuries, not even by thousands of years, but by millions. Back to the Miocene epoch, about 10 to 5 million years ago. At that time, Europe wasn't full of castles, cities, or farmland. It was wild. There were dense forests and wide grasslands, rivers twisting through rocky valleys, and animals we can't even imagine living today. Saber-toothed cats. Giant rhinos. Ancient elephants. And apes. Lots of them. In fact, scientists now believe that Europe was once full of apes, more than Africa in some time periods. It wasn't just Ouranopithecus wandering the landscape. There were others, relatives, cousins, maybe even ancestors. Let's meet a few of them. First, there's Grycopithecus freybergi. This one might be even older than Ouranopithecus. It was discovered in Greece too, in a place called Pyrgios Vasilissus near Athens. The fossil was small, just a lower jaw and a few teeth, but those teeth told a big story. They looked human-like. The premolars were partially fused together, a trait that some scientists say is seen only in hominins, the group that includes us and our direct ancestors, but not chimps or gorillas. The age of the Grycopithecus fossil? Around 7.2 million years old. That's older than the earliest known hominins in Africa, like Sahelanthropus jodensis, which is dated around 7 million years ago. That shook things up. If Grycopithecus really was a hominin, then that would mean the human lineage began not in Africa, but in the Balkans. Then there's Anadoliavius turci, a fossil found in Turkey. This one was discovered more recently and dates to about 8.7 million years ago. It shares many traits with Ouranopithecus, which suggests they might have belonged to the same extended family. The face is broad. The jaw is strong. The teeth? Once again flat, thick, and capable of crushing hard foods. Scientists studying Anadoliavius say it shows adaptations for both climbing and walking. Not fully upright, not fully tree-bound. But somewhere in between. And again, it wasn't found in Africa, it was found in central Anatolia, which is in modern-day Turkey. That puts another pin on the map, another piece of the puzzle suggesting that Europe and the surrounding regions were more than just sidelines in human evolution. They may have been the starting line. So, what happened? If there were so many ancient apes in Europe, why didn't they survive there? The answer is, climate. The Earth was going through massive changes during the late Miocene. Temperatures dropped. Rainfall patterns shifted. Forests shrank. Open woodlands and grasslands began to take over. And Europe? It started to dry out. Many of the ape species that depended on thick, humid forests began to disappear. Others like Ouranopithecus seemed to adapt, but only for a while. Eventually, most of them vanished from the fossil record in Europe. But here's the twist, around the same time these apes were vanishing from Europe, similar apes began appearing in Africa. Coincidence? Maybe. But more and more scientists are wondering, what if those apes didn't just vanish? What if they migrated? Imagine this. A group of Ouranopithecus or perhaps one of their close relatives is struggling in the changing climate of Greece. Food is getting scarce. Forests are turning to dry brush. Predators are everywhere. But there's a path south. Across the eastern Mediterranean. Maybe through what's now Turkey, Syria, and Lebanon. A land bridge. A corridor. One that leads into Africa, where the environment was still more stable. So they walk slowly. Generation by generation. Moving toward better land, better food, better chances. And when they arrive in Africa, they find new challenges but also new opportunities. They adapt. They evolve. And over millions of years, they become something new. Australopithecus. Homo habilis. Homo erectus. Us. If that's true, then the story of human origins isn't just African. It's Eurasian African, a journey that began in the forests of Europe and found its future on the plains of Africa. Of course, not everyone agrees. Some scientists argue that the similarities between Ouranopithecus and early hominins are just coincidences. Others say the fossils are too fragmentary to be sure. After all, we don't have full skeletons, just skulls, jaws, and teeth. And without the rest of the body, it's hard to say exactly how these apes lived, moved, or evolved. But isn't that the point? Science isn't about knowing everything. It's about asking the right questions. And Ouranopithecus is the kind of fossil that makes us ask all the big ones. What makes a hominin a hominin? Is it just walking upright? Is it the shape of the teeth? The size of the brain? Or is it something else, something harder to measure, like adaptability, intelligence, or social behavior? We don't have all the answers. Not yet. But Ouranopithecus, Grycopithecus, Anadoliavius, and their forgotten cousins are whispering clues from deep in the past. They're telling us, look here. Look deeper. Don't ignore us. One night, I printed out pictures of the fossils and made a giant timeline across my bedroom wall. From Proconsul to Sahelanthropus to Australopithecus to Homo sapiens. I placed Ouranopithecus right in the middle, with a big question mark next to him. Above it, I wrote, what if the beginning didn't happen where we thought? And every time I look at it, I think about those apes in the forgotten forests of Europe. The ones who climbed, chewed, survived, and maybe just maybe gave rise to everything we are. I once saw a bird migration map in a nature documentary. Arrows moved across the screen, showing how birds travel thousands of miles every year, crossing continents just to survive. It got me thinking, if birds do that every year, could ancient apes like Ouranopithecus have done something like it once, too? Except this time, the journey wasn't seasonal. It was permanent. Not a sprint, but a slow walk through history. In this part, we're going to trace a possible journey, a path from the crumbling forests of ancient Europe to the savannas of Africa. A journey that could explain how Ouranopithecus, or one of its close cousins, helped set the stage for, well, us. It's around 8 million years ago. The world is changing. The thick, moist forests of the Mediterranean are drying out. This isn't a quick change, it's slow, stretching over thousands of years, but it's relentless. In places like northern Greece, where Ouranopithecus once thrived, the land is turning harsher. Shrubs replace trees. Streams dry up. Food becomes scarce. Apes who lived comfortably in the canopies now face danger on the ground. This is the turning point. Some species go extinct. Others shrink in number. But a few, perhaps Ouranopithecus among them, adapt. Instead of depending solely on fruit from trees, they start eating tougher vegetation, nuts, seeds, roots. Their powerful jaws and thick enamel give them an advantage. They don't need soft fruit anymore. They can chew the dry, crunchy stuff. The kind of food you'd find in a more open environment. That makes them flexible. Survivors. And it sets the stage for something incredible. Now, let's imagine this. A group of Ouranopithecus families, maybe a dozen individuals, starts to move. Not because they're trying to go somewhere far, but because the forest around them is disappearing. Every year, it shrinks a little more. So they move with the food. Slowly. Just a few kilometers at a time. South. Then east. Then south again. They pass through what is now modern-day Turkey. Back then, it was still lush in places, rivers, scattered trees, pockets of forest. Fossils from this region like Anadoliavius suggest that other apes were living here too, similar in structure and diet to Ouranopithecus. Maybe they were cousins. Maybe some of them were even interbreeding. Scientists can't say for sure, but the similarity in skulls and teeth is hard to ignore. And the terrain? It was survivable. There were natural pathways, not blocked by oceans or mountain ranges. The Levantine corridor, stretching through modern Syria, Lebanon, and Israel, was a green belt of land between deserts. Perfect for migrating species. Eventually, this pathway led into northeastern Africa, places like Egypt and Sudan. That's where the next chapter begins. Now here's where the theory becomes really interesting. In Africa, the fossil record is rich. We find Sahelanthropus chodensis in Chad, dated to around 7 million years ago. Then Ouranopithecus in Kenya, around 6 million years. Then Ouranopithecus, Australopithecus, and the early members of the Homo genus. They all lived in Africa, no doubt about that. But what if their ancestors didn't evolve there? What if they arrived? Ouranopithecus, or perhaps a close relative like Grycopithecus, might have been part of a small wave of primates that crossed from Europe into Africa between 8 and 7 million years ago. Once there, they adapted again. The climate was different. There were new predators, new foods, new challenges. And then, something remarkable might have happened. They stood up. Or, maybe they had already begun standing up before the migration. The fossil evidence doesn't give us a clear answer. But at some point in this timeline, bipedalism, the ability to walk upright on two legs, took root. Walking upright changed everything. It freed the hands for carrying food or tools. It allowed better visibility over tall grass. It reduced exposure to the sun. And once this trait appeared, it gave early hominins an edge. And it led to all kinds of new evolutionary steps: smarter brains, longer childhoods, more complex communication. All the things that made us human. So the question becomes, where did the first bip stand? Was it Africa? Or was it Europe, with Ouranopithecus and its family? We don't know for sure. But if Ouranopithecus or its relatives were the ones to take those first wobbly steps, then that path from Greece to Africa wasn't just a survival route. It was the road to humanity. There's another clue, one that doesn't come from bones, but from something even older: plate tectonics. Millions of years ago, Africa and Europe were much closer. The Mediterranean Sea wasn't as wide or deep as it is today. In fact, there were times when the sea almost dried up completely. One major event, called the Messinian salinity crisis, happened around 5.9 million years ago. The Mediterranean began evaporating, turning into a hot, salty basin. Land bridges appeared. Animals could cross between continents more easily. By then, Ouranopithecus was probably gone. But if earlier primates had already started migrating south before that, it would have been even easier during this time. Nature gave them a bridge. And they took it. Skeptics argue that this Europe to Africa idea is too thin. That there's not enough fossil evidence to back it up. But every year, more fossils are discovered in new places: Bulgaria, Serbia, Turkey, and other parts of Europe that haven't been explored as much. And guess what? Some of those fossils show similar traits: thick enamel, short faces, powerful jaws. The more we find, the less crazy the theory sounds. In fact, some scientists now suggest that the last common ancestor of humans and chimps may have lived in Europe, not Africa. If that's true, it changes how we understand everything. It means the human story didn't start in one place. It started in movement. In my sketchbook, I've drawn a map showing a dotted line from Greece to Kenya. I put a tiny ape figure at the start of the line and a tiny human at the end. Below it, I wrote, what if the first human wasn't born, but walked into history? That line isn't a straight path. It twists and turns. It's interrupted by rivers and deserts, volcanoes, and seas. but it connects two great continents and two great ideas, the known and the unknown. And along that path, Ouranopithecus might have walked. Slowly. Carefully. Forward. Even now, scientists are still out there digging, brushing away dirt, hoping to find a piece of that journey. Maybe a foot bone, or a pelvis. Something that says, yes, this one walked upright. Something that proves the path really existed. Until then, the story of the southward journey is part science, part mystery, and part imagination. But every story starts with a single step. And maybe just maybe Ouranopithecus took it.